All right, so we have a 15 kilogram box being pushed by a girl across a carpeted floor, and there's an acceleration of 2 meters per second squared, and we want to know what force the girl pushes the box with if we have a given coefficient of friction. So first, let's begin with the free body diagram, as we are asked to do. So there's a normal force, here's the weight force, we have a pushing force, and we have a friction force right here. So with that in mind, we push, we've got friction, and the effect is, since the forces are unbalanced, that the box accelerates. Let's go ahead and calculate, though, that kinetic friction force. So to get that, we know that the normal balances the weight, in this case when I look at the free body diagram. So that's going to be 15 times 10, which is going to give me 150 Newton normal force. And keeping that in mind, the friction force is going to be mu times the normal force, mu kinetic times the normal force, and that's going to be 0.2 times 150, which gives me 30 newtons. Awesome. So continuing with that, I've got this unknown applied force fighting the friction, and the effect is that this 15 kilogram box accelerates at 2 meters per second squared. So finally, when we solve, we're going to get an applied force of 60 newtons. Awesome. So now we're going to keep this applied force the same, but our acceleration is a little less when we want to figure out what the friction force is. So once again, we have the applied force minus the kinetic friction force, since it's moving, makes the mass accelerate. So 60 minus this new friction force makes our 15 kilogram object accelerate at 1 meter per second squared. So that means our kinetic friction force ends up being 45 newtons, but we want the kinetic coefficient of friction. So keeping in mind that our normal force is 150 newtons, let's get that coefficient of friction. So that means 45 is going to equal mu k times 150. And so when we simplify, mu k ends up being 0.3. Now we want the speed of the box after 3 seconds, assuming the acceleration is what was given in part B and the box starts from rest. So let's do that. V equals AT plus U. So we're going to say V equals 1 times 3, which is 3 meters per second. All right, now, the last part, let's do part D. All right, now, the girl, let's go to the box. Force of friction from B still acts on the box. We're going to determine the acceleration of the box and use this to determine the time it takes the box to come to rest, etc., etc. So the free body diagram is going to look like this. We've got a normal force, we've got a weight force, and we've got a friction force right here. And so what we have here is, it's kind of like we'd have an applied force of 0 here. So 0 minus the force of friction is going to equal my little m times A. Our friction force from previous is, we're going to say here it's that 45 newtons equals the mass, which is 15 times A. So A is in fact -3 meters per second squared. And so we can just use V equals AT plus U. 0 equals -3 times T plus the 3 meters we got, 3 meters per second from before. And that's going to give us a time of 1 second. So that's page 5. I'll get the rest of these videos up in the next segment.